Hello friends and welcome back to the channel. It's been just over 2 months since we built the NECKAR boat, a small world made from river mud, plants and a bit of curiosity. Since then, so much has changed. What started as a handful of sediment and invisible life has grown into a miniature self-sustaining ecosystem. In this video, we'll look at which species survived, which disappeared, and which new ones somehow found their way in. And I'll also share a small experiment I've been a part of, together with Matt from Matt Keeps Fish, involving a few mysterious Ramshorn snails. Let's jump right in. My journey started just past 6 AM here in Heilbronn. The city is still asleep. Streets are quiet and I'm heading out on my little expedition. I got some buckets, nets and all the gear I need. Today I'm on my way to collect some materials to start a small ecosystem bowl at home. Saturday mornings are my favorite for doing this. No traffic, barely anyone around, just me and the sound of my footsteps through the city. Feels like the whole place belongs to you for a while. Curious to hear whether you guys are familiar with these streets here. If you are, please comment below. As I move out of the center, the concrete slowly gives way to trees and open space. It's a strange but beautiful transition, walking from stone and glass into something alive and breathing. This is my destination, a local park with ponds and small lakes. Perfect little pockets of life. And if you look closely, these places are full of hidden ecosystems, waiting to be explored. When you check the camera footage, and this is also something that was apparent from above, there's not much life in there. So I have to look for another, more vivid spot. And my journey takes me some 100 meters across this local pond, or should I say lake, to the small wooden footbridge here. And it is here where I actually spotted the perfect place to collect some dirt. Let's first have a look under the water. So you see there's way more biological activity going on in this area, so I think this is the perfect spot to collect some dirt. And what I'm doing here is I'm gathering some pond soil, some water and a few aquatic plants. Nothing too big, just enough to create a balanced little world in a jar. Each scoop is like a seed for a tiny universe. You might not see it at the moment. It just looks like dirt. But in a few minutes we will have a thriving ecosystem made out of all of this dirt. Some of these creatures you can't even see with the naked eye, and some are rather big. I also want to dig into this huge algae patches here, because I assume that there's a lot of insects and crustaceans in there. I think there won't be any fish in there, just rather big insects. You can also see some of them swimming and jumping around in there at the moment, but nothing too big yet. Next thing we have to do is collect some more water. What I like to do when setting up these kind of projects is I like to take water from different spots in the local pond where I am, so I increase the chances of getting as much biodiversity as possible. And also this smell test is something that I would advise you guys to do, because if you have very smelly things, usually your jar ecosystems might rot, and this is something you don't want to do if you have in your living room and if you want the animals to survive, right? One of the first plants I'm collecting today is bogbean, Menyanthes trifoliata. It's a wetland species that often grows in shallow water or along the muddy edges of ponds. The leaves are easy to recognize, 3 leaflets that almost look like a clover floating on the surface. In spring, it produces delicate white flowers that attract insects. But even when it's not in bloom, as it is today, bogbean plays an important role in pond ecosystems. It helps to oxygenate the water and provides shelter for small creatures. Another plant I'm taking today is yellow flag iris, or Iris pseudacorus. This one is much more striking, tall, bright, and impossible to miss when it flowers. It thrives in the wet edges of lakes and streams, and its roots act like natural filters, cleaning the water as it grows. In a small jar ecosystem, it brings both structure and resilience. I'm only collecting a few specimens of each. It's important to be careful with plants like these. They're part of a bigger system here. Taking too much could disturb the balance, so I just gather what I need, leaving the rest to thrive in the pot. The centerpiece of this project is a simple glass bowl. My mom actually found it in the garbage, and today it's getting a second life. Before anything else, I give it a thorough clean. Just water and a clean cloth. No soaps or detergents. I want to make sure nothing harmful makes its way into the ecosystem. For the foundation, I'm using a layer of aquasoil that was left over from an old project. It's rich in nutrients and gives the plants a good base to root into. On top of that, I add a layer of white sand, also left over, this time from the tank project you can actually see in the background. By the way, if you want to see how that tank developed, there's a link on the top right corner you can check out. Before planting, I take a moment to flatten the sand bed. It's a small detail, but there's something almost therapeutic to it. Like working on a miniature Japanese sand garden. The surface becomes calm and level, a blank canvas for this little ecosystem. I begin with the yellow flag iris. In nature, this plant grows along riverbanks and wetlands, where its roots act like a living filter, pulling impurities from the water. In our small ecosystem here, it helps to stabilize the soil and keep the water clear over time. Its tall leaves will also give some vertical structure, hinting at the feeling of a shoreline inside the bowl in my bathroom. Next comes the bogbean. This plant has a very different role. In the wild, its floating leaves shade shallow waters and give cover to small creatures like insects and amphibians. Even here, in a tiny glass bowl, it can create microhabitats, breaking up light, slowing down water movement, and providing surface area for microorganisms to settle on. To anchor the plants and add some visual balance, I place two larger rocks. They'll hold down the roots until the plants are firmly established. And at the same time, they create a sense of scale, like little boulders in a landscape. Before pouring in the pond water, I add a layer of plastic, just a plastic bag and a plastic lid. This way, the water won't disturb the sand or unroot the plants. It's a simple trick, but it makes all the difference in keeping the foundation intact. With the plants in place and everything secured, the stage is set. Next comes the most important step, introducing the pond water, and with it, the invisible life that will bring this miniature world to life. Ten days have passed since setting up this little ecosystem, and it has begun to settle into balance. Today, I'm adding tap water for the very first time. Room temperature, poured carefully. The fresh water stirs things up a bit, sending tiny clouds of sand and debris drifting through the bowl. And with that disturbance, one of the first true inhabitants reveals itself, a Mayfly nymph. Mayflies are fascinating creatures. They belong to one of the most ancient groups of winged insects, relatives to dragonflies and damselflies. But unlike their cousins, mayflies spend almost their entire lives underwater as nymphs, sometimes for a year or more, before transforming into the short-lived adults that give them their name. They're called mayflies because in many regions the adults emerge in large swarms during spring and early summer, often in May. In this aquatic stage, the nymph breathes through delicate gills along its abdomen, fanning them to move water and extract oxygen. It spends its days grazing, feeding on algae, plant debris, and the fine organic particles that collect on leaves and rocks. Their gills are delicate leaf-like structures that are located along their abdomen, and you will often see them fanning these gills to pump water across the surface. A behavior that helps them to extract oxygen from water, but in some Mayfly nymph species, these movements also stir up fine food particles in the water, and I think that's also the case for this species if you look at it closely. There are over 3,000 species of mayflies worldwide, and their nymphs come in three broad ecological forms. Swimmers, which dart through the water column, clingers, which grip onto rocks and plants, and burrowers, which dig into mud and sand. The one in my bowl, that you can see here, is wandering freely over surfaces in search of food. You can also see a shot of one of the smaller Mayfly nymphs here that is trying to eat some debris that is hanging on this plant. They are close relatives of dragonflies and damselflies, but unlike those predators, they are generally considered grazers. And here we see an interesting encounter. The Mayfly nymph approaches a bladder snail. But when the snail suddenly swings its shell, the nymph backs away. It's a reminder that even in tiny ecosystems like this, there's a constant dance of interactions. Creatures negotiating space, testing boundaries, and responding to each other's movements. For now, the Mayfly nymph is a quiet, almost hidden resident, but as this little world develops, its story will continue to unfold, alongside the plants, snails, and countless other tiny lives within the bowl. While the Mayfly nymphs spend their whole existence underwater, another resident of this bowl lives a very different kind of life, the bladder snail. And unlike the delicate, gilled nymphs, these snails are air breathers. They belong to a group called pulmonates, meaning they have a simple lung that lets them take in oxygen directly from the air. This gives them a big advantage in environments where oxygen levels can drop. Because while Mayfly nymphs would struggle, bladder snails can simply rise to the surface, extend their siphon, and take a gulp of air. This is a huge advantage in many ecosystems around the world where bladder snails are present, because bladder snails are originally from North America, but in 2025 they have spread through all continents worldwide except for Antarctica. Although I'm sure that maybe in the future we will even find them there. And bladder snails are surprisingly adventurous for such small creatures. So here you can see one climbing the bogbean leaf that is almost completely degraded. It's devouring what's left over, so it's filling a very similar ecological niche to the Mayfly nymph. However, here you can see one of them climbing the central bogbean stem, several times its own size. It spends a few minutes exploring, grazing the thin biofilm, layers of bacteria and algae that coat the surface of the plant, and these snails are excellent scavengers, feeding not only on biofilm but also on decaying leaves and leftover organic matter. In doing so, they recycle nutrients and help keep the system clean. Among all the creatures in this jar, the largest and perhaps the most fearsome is the dragonfly nymph. Unlike the grazing mayflies and snails, this is a true predator, a hunter perfectly adapted to life in the shadows of ponds and lakes. Dragonfly nymphs feed on almost anything they can overpower: mosquito larvae, small crustaceans, worms, and even other insect nymphs. In larger ponds, they are capable of taking down tadpoles and even tiny fish. The key to their hunting success lies in a weapon unlike anything else in the insect world: the extendable lower jaw, called a labium. Normally, it is folded under the head like a hidden arm, but when the prey comes close, the nymph fires it forward in a fraction of a second.
grabbing the victim with hook pinchers at the tip and pulling it back into its sharp mandibles. This ambush lifestyle, powered by patience and explosive speed, makes the Dragonfly Nymph the apex predator of this tiny ecosystem. While other inhabitants scrape algae or graze on biofilm, this Dragonfly Nymph lives by stealth, strike, and capture. Most of the time, this jar seems calm, even still, but if you zoom in and speed up the footage 10 times, 25 times, even 100 times, an entirely new world appears. Tiny organisms, almost invisible to the naked eye, dart and drift through the water. At this scale, the ecosystem is buzzing with life. Even the Mayfly Nymphs reveal another side of their lives. At this speed, you can actually see them chewing away the decaying bogbean leaves, breaking down plant matter and recycling it back into the system. But the surface tells its own story. It's almost like a separate ecosystem with its own inhabitants and its own dramas. Here, two bladder snails meet, and for a brief moment, there's a little love scene in progress. Bladder snails are hermaphrodites, meaning each one carries both male and female organs, and encounters like this ensure the next generation is never far away. What do you think? Are bladder snails fascinating little pets or just test snails? Discuss below and let me know. And then, among the snails, we find a different kind of inhabitant. Another tiny predator, mosquito larvae. They hang just below the surface, moving in stiff, robotic jerks, feeding on microorganisms and hunting even smaller prey. Mosquito larvae are almost alien in the way they move, dangling from the surface film like little robots, then snapping into motion with a stiff, twitching jerk. They breathe through a siphon at their tail end, which they poke up through the surface tension to take in air. This makes them completely dependent on the surface layer where water meets air. And when it comes to diet, mosquito larvae are filter feeders and scrapers. They sweep tiny brushes around their mouths to put in microorganisms, bacteria, protozoa, and algae, and bits of organic detritus suspended in the water. In a way, they are recyclers just like the Mayfly Nymphs and bladder snails, but unlike them, they remain tied to the surface ecosystem. And on larger ponds, the surface isn't only home to larvae. Another iconic inhabitant is the water strider. These insects have legs coated in tiny water-repellent hairs that allow them to skate across the surface tension as if it were solid ground. They are surface hunters, detecting ripples made by struggling insects and darting in to seize them with needle-like mouthparts. Water striders reproduce right there on the surface too. Males court females with tapping vibrations, almost like Morse code, sent to the water film, and the eggs are laid on submerged plants or debris, where the next generation begins. And in case you wondered how this ecosystem is fed, here I'm taking off one of the leaves of the yellow flag iris, and I'm just returning it to the little bowl below. And right away, it's not going to be a food source for the animals, but within some days, this will degrade and then all of the animals can start eating it. So the Mayfly nymphs, the bladder snails, but also smaller animals we cannot even see, these animals will then feed the predators, and then the cycle can continue.
2 months have passed since we built the NECKAR bowl ecosystem, and at first glance it looks like a lot has changed. The water level has dropped, the glass is covered with brownish stains, and the surface that once shimmered with life now seems quiet, almost still. The bogbean that was thriving only weeks ago has completely vanished. only a pale silhouette remains, a ghost of what once looked strong and healthy. Has this tiny world really turned into a lifeless desert in just 2 months? To find out, I start by cleaning the glass with a simple sponge, carefully, to avoid disturbing the fragile balance inside. Then I trim back the dead bogbean leaves and stems with my aquarium scissors, and as always I leave them in the bowl. They'll slowly decompose and provide nutrients for everything that's still alive. But despite this first impression, not everything in here has suffered. The yellow flag iris, pseudacorus, has done surprisingly well. Its sword-like leaves have nearly doubled in size and length, reaching far above the water's surface now. It's clearly adapted to this environment, thriving where other species fail. And it's not the only form of life that has done well. If you look closely, you'll notice movement on the glass. Tiny snails, slowly grazing on the algae layer. They've multiplied rapidly, maybe too rapidly. But before we get into that, let's start by restoring some of the lost plant life. To compensate for the bogbean, I'm adding a few plants that don't naturally occur in the Neckar River, but that I know from experience can thrive in this kind of low-tech, cold water setup, cryptocorynes. They don't need warm water or artificial lighting, and these specimens are already adapted to colder conditions. I'm planting 3 of them, carefully spacing them around the center of the bowl. Next, I'm adding a large water lily to take over the ecological niche that was once occupied by the bogbean. Like the bogbean, it prefers calm and shallow waters, and it has proven in other setups that it can thrive in exactly these conditions. The peace lily, on the other hand, looks surprisingly healthy. Its leaves are juicy, vibrant green with delicate white stripes running through some of them. It's clearly enjoying the humidity and the gentle morning light above the bowl. When we move over to the yellow flag iris again, its sheer size becomes apparent. From the roots all the way to the tip of its tallest leaf, it now measures a whopping 22 inches, or 56 centimeters. Almost twice the height it had just 2 months ago. Back below the surface, the camera reveals the intricate root system of both the water lily and the newly added cryptocorynes. It will take some time for these roots to fully anchor themselves into the sediment, but even now you can already see some fine roots spreading above the soil. These exposed roots aren't a problem, quite the opposite actually. They'll increase the surface area for biofilm growth, and that biofilm will provide food for countless tiny grazers, many of which once thrived in this ecosystem. The Mayfly Nymphs, however, are gone. The delicate water striders too disappeared without a trace. Most likely they were picked off one by one by the massive Dragonfly Nymph that once ruled this bowl for weeks. But even that predator vanished. I'm fairly certain it metamorphosized into an adult dragonfly, because about 4 weeks ago I saw one flying through my room. Unfortunately, it disappeared before I could take a picture, but I like to think that it was my dragonfly, finally escaping the miniature world it grew up in. And the mosquito larvae, they definitely made it out as well. I'm 100% sure, because they bit me while I was working on a very advanced PowerPoint presentation. The circle of life. Sometimes it comes full circle in unexpected ways. Now, let's focus on the species that currently call the Neckar Bowl home. And first and foremost, the bladder snails. Their population has exploded. In this shot alone, filmed at 50x speed, you can actually see 3 or 4 different generations crawling over the glass and plants. Tiny juveniles with nearly transparent shells, medium-sized sub-adults, and the fully grown adults, each one busy cleaning surfaces and searching for biofilm. There are several reasons why bladder snails might have become the dominant species in this miniature ecosystem, at least among the larger visible animals. First, they are incredibly resilient. Bladder snails can survive low oxygen levels, stagnant water, and even short dry periods by sealing themselves inside their shells. When the water level dropped during these 2 hot months, they were the ones who simply waited it out. Secondly, they are opportunistic feeders. These snails eat pretty much anything: decaying plant matter, algae, leftover detritus, and even biofilm on the glass. When other species starve or vanish, bladder snails still have plenty to eat. And third, they reproduce like crazy. Every single individual is a hermaphrodite and capable of producing offspring on its own. So, even if only one snail had survived the dry phase, it could have repopulated the entire bowl within weeks. That combination, resilience, flexibility, and self-sufficiency, makes them the perfect colonizers for tiny, unstable ecosystems like this one. But the bladder snails are not the only ones thriving here. When I take a closer look at the sediment layer, I noticed something unusual. A much larger snail species slowly moving through the sand. These are red-rimmed Melania snails, also known as Menyanthes tuberculata. They are not native to the NECKAR river, which means they somehow hitchhiked their way into this bowl. And the crazy thing is, I'm pretty sure they came in through dry substrate. The aquasoil and sand I used here was actually reused from an old escape, if you remember. That means some of their eggs or juveniles must have survived completely without water for who knows how long. And it really makes you think, just how long can these snails stay dormant? Weeks? Maybe months? If you know it, drop it in the comments below. And yet, the moment the mother returns, they somehow wake up and start crawling again, as if nothing ever happened. Nature really is full of tiny miracles like that. Third and last snail in this little world is the Ramshorn Snail. You can see it here, peacefully grazing on the Vallisneria leaf in the back section of the bowl. The Vallisneria leaf is just a cutting I put in there for additional nutrition. Its slow movements, the way it glides upside down along the leaf, almost look like it's tracing the veins of the plant, turning every bit of biofilm into a meal. And this particular snail is part of a small experiment I'm doing together with my friend Matt from the YouTube channel Matt Keeps Fish. If you enjoy these kinds of tiny ecosystem projects, you should definitely check out his channel. He does some incredible research on aquarium life and has amazing videos. The idea behind this experiment is to find out whether Ramshorn snails are capable of self-cloning, also known as parthenogenesis, a process where an organism can reproduce without a mate, creating genetically identical offspring from a single parent. It's an ability that exists in some snails, insects, crustaceans, and would make perfect sense for species living in small, isolated environments like this one. Ramshorn snails, like bladder snails, are hermaphrodites, meaning each individual carries both male and female organs. In theory, that means one snail should be able to start a population on its own. But in Matt's carefully controlled experiment, his single Ramshorn snail never produced any offspring, even though conditions were perfect and just the same as in the control group. So, despite their hermaphroditic anatomy, they might still require another individual to trigger reproduction. It's fascinating, because it shows how even the simplest creatures don't always follow the rules we expect. Some depend on cooperation, even in a world as small as a glass bowl. And then there's life that's much harder to see, tiny, almost invisible creatures that move like specks of dust through the water. But these specks are alive. They are Copepods. Copepods are amongst the most common aquatic animals on Earth, and it's almost certain that the species in this bowl originated right here in the NECKAR river. Most freshwater copepods in Germany belong to the genus Cyclops, named after the single black eye that gives them their characteristic look. First thing you notice under a microscope is their jerky, pulsing way of swimming. They move in little bursts rather than gliding smoothly. It's this movement that allows them to quickly escape predators or dart towards floating particles of food. The second fascinating thing about copepods is how tough they are. They survive in water that's too cold, too hot, too low in oxygen, or too stagnant for almost anything else to live. Even when a pond dries up completely, some species lay resting eggs that can remain dormant in the sediment for months, sometimes even years, until conditions return to normal. And third thing is that these creatures are the cornerstone of freshwater ecosystems. They graze on bacteria, algae, and detritus, and in turn they become food for fish fry, insect larvae, and larger crustaceans. They are, in a way, the quiet engine that keeps small ecosystems running. But while observing the bowl, something unexpected caught my eye. As I was cleaning the glass and trimming the dead bogbean stems, I saw a small shadow dart through the sand. A shape that didn't belong to any snail or insect. And there it was, a Scud, a single amphipod, alive and well after 2 months of complete neglect. I couldn't believe it at first. Scuds were part of the original community, but I hadn't seen a single one since the last update. And yet, here it was, alive, moving, searching, a survivor in a world that seemed empty. Like Copepods, Scuds are crustaceans, but they belong to a different order called Amphipoda. They have flattened bodies, bent legs designed for hopping and crawling, and they feed on anything they can find, dead leaves, algae, or leftover detritus. Copepods, on the other hand, belong to the subclass of Copepoda. They are much smaller and more planktonic. They live in the open water, while Scuds prefer the ground and are hiding under debris. Despite their differences, both species play a similar ecological role. They recycle waste, keep algae in check, and serve as food for just about everything larger than themselves. Together, that even in a sealed glass bowl, with no filtration, no feeding, and no maintenance, life finds a way, quietly, persistently, and beautifully. If you enjoyed diving into the NECKAR bowl ecosystem, please leave a like and subscribe. It really helps me keep exploring these miniature worlds, and if you want to see how my larger 63-gallon tank evolved over 330 days, check out the video on the right hand side.